something's missing here. What is missing?
Big A.
B.
Little B. Angle A.
You're not answering the question the way I'm thinking. You said that.
You don't even need the triangle.
There we go. I recommend that you draw a triangle every time when you realize it's angle side side. But how do I know this is angle side side? You've got one angle, you've got the side that matches with it, and then you got this other guy, the lone wolf. Okay, so that's the telltale sign for angle side side. And you may remember that I've instructed you. I feel like best practice is to put the given angle down in the bottom left. Now that's big C. So the other side is going to be little c. Now that's 7. And then this odd man out, so to speak, is going to be 15. This is how I recommend you draw it out every time. Okay. Now, Michael, Estep, you with me? What are our 3 possible scenarios with law of signs? Not when should we use law of signs, but like what kind of situation might we find ourselves in? No. That's not what I'm getting at. Like how many solutions might you have? How many possible triangles might? I'm thinking of a person who's wearing a dark piece of outerwear and has brown hair. You know what I'm saying? Could I be describing more than one person? What if I said dark outerwear, brown hair, and they're 8 feet tall? Could I be describing 0 persons? Yeah. Okay, so talk to me about that. What scenarios might we find ourselves in here as far as triangles? All right, perhaps we need a refresher. Do I have it on this page? Okay, there we go. That's what I was shooting for. And my question was a bit ambiguous. Okay, so yeah, this could be no solutions. It could be one solution. Maybe it could be 2 solutions. Kenneth loses laptop. Jack loses laptop. Michael loses laptop. Eli loses laptop. It was supposed to be an officer powers thing because I said the word ambiguous out of context, but in context. All right, so how I know whether it's 0 solutions, 1 solution, or 2 solutions is I get my hands dirty. I isolate the missing angle. Now let's see here. This is big A. I isolate big A. We go to the Mexican restaurant and we pick 2. Right? So which 2 are we going to pick, Henry? All right, very good. So let's do the sine of big A over 15 equals the sine of 30 over 7. Notice I'm putting my variables up top. I find that to be best practice. But you, like we said, you do whatever floats your boat. Okay? Good morning. Hey, fantastic job.
I gotta help him out. I'm dropping off my bag.
Do what?
I gotta help him out with those equipment bag.
Oh, you're just dropping your bag off. Okay, well, hustle up. First step we're going to do is multiply by 15. That should be easy. All right, Kenneth, here's the hard part. What do I do next? We multiplied both sides by 15. I've got sine of A equals some number. How do I get big A by itself? Come on, man. Solve for an angle, use that. Inverse sine. Very good, Kenneth. You came through clutch. I love it. So we're going to do inverse sine of both sides. So I got big A equals inverse sine of whatever that fraction is, whatever that number is. Sine 30 over 7. We're going to run the numbers. Okay. Now you need a what?
Go.
Get your calculator out. All right.
Thank you.
All right. So you guys are starting to see. Oh, this always happens. Hold on. Get on out of here. There we go. No. Yes. That's what I want. You get out of here too. All right. We're going to clear that. And I'm going to do inverse sine of 15. Sine 30, just type it in my stuff, close parentheses. We'll make it a fraction, 15 sine 30 over 7. Get out of there, close parentheses, hit enter. Bum, 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 bum. Okay, we got no possible answer there. So that means that there is no solution for this problem. Okay, so if I get an error message and I have set things up properly, that means that this is like saying I got somebody that's wearing dark outerwear, has dark hair, and is 8 feet tall. No, you don't. There's no such triangle that has 30 degrees, its opposite side is 7, and this side next to it is 15. Here's why. Okay, the height of this triangle is 7.5, and therefore this leg over here, this 7, is too what?
Short.
It's too short. You can't reach that base because although, however you swing it like a pendulum, you're not going to hit that base any because that height has to be at least 7.5. Or no, excuse me, that height is 7.5. And so that side C would have to be at least 7.5.
That's the height of
All right. Now I made this problem easily knowable. Bless you. Easily knowable because what's this angle right here?
36.
And what's the sine of 30 degrees?
So what is
1/2. Very good. And so 7.5 over 15. You know what I'm saying, Mitchell?
Yeah.
And that's a great question. That's why I made this as an easy example, because before you realize there was no solution, we're sitting here chugging along working, and then we get this error message and we think no solution, and it's easily provable because that altitude is gonna have to be 7.5. Thank you. I think you've missed the boat here. There is no second triangle. There is no first triangle. There is no possible triangle. Nash? Find the height first? Yeah, if it's easy, you're not going to have 30 that often. But you know, like if this was like 37 degrees, then I would to calculate that height. Let's pretend like it's 37 degrees. All right, so let's pause for a sec. Let's pretend like this is something where I don't necessarily know what that height is. I've still got a right triangle, and like Franklin was kind of saying there, the sine of 37 degrees would equal h over 15. So I'd times both sides by 15, and then I'd have h equals whatever that is. Somebody run those numbers for me real quick. All right, so height was be about 9. And so like if we were running into a situation like that and we said, well, hey, my height has to be 9, womp womp, that 7 is way too small. Now let's say that 7 was a 10. Is it long enough now?
Yeah.
You daggum right it is. And in fact, it's so long that it could swing back and hit twice. And that would be like the example we looked at yesterday where there was 2 solutions. Okay. What if that 10 wasn't a 10, but what if it was something that's so doggone big? Let's say it's a 20. All right, let's say that's a 20 right there. Could I possibly swing it back to the left? No, because it's way bigger and way longer than 15. The only way I could swing it, that would be where you've got the one solution scenario, where it's so big. Okay.
Wait, so what's the original problem? Or like the original number, that's 7.5. 15.
I just boxed it.
Wait, so 7.5 lost her there, so why would that, we didn't have to put one over yet.
The height was 7.5 and this side was 7, and so it wasn't long enough. It was too short. Yes. All right, next example. This one was easy because it was no solution. Let's see what we think about this one. Again, are you practiced at drawing it out? BJ, where are you going to put that 72 degrees? Good. Bottom left. 72 degrees. Now that's big A. So that means that little a across from it is 7. We're going to put there. There's big B. There's big C. There's little c. You ought to be able to make your triangle lickety-split. If you draw it the same way every time, there's no question. If you draw it the same way every time, you're rock solid. Okay. Now, we're going to ask Jack to set me up. Jack, you want to set me up with a little Mexican restaurant, pick 2, create your own combo? You told me sine of A, so I just went ahead and wrote 72, although you didn't say 72. So I did sine of 72 over 7. That's 1. That's a fully known fraction. Now, what's your other fraction that you want to pick? Do you want to do sine of C over little c or sine of B over 6? Good, because if I pick sine of C over little c, that's too many unknowns. I don't know either one of those. It doesn't help. So sine of big B over 6. And then, Eli, what's your first step? Multiply both sides by 6. Aiden, what's your next step? This is what Kenneth helped us with in the last problem. I want to get sine out of there. I want B by itself. What's the way to undo a sine? There you go. So your inverse sine function. So we're going to take inverse sine or arc sine of both of those sides of that equation to get big B by itself. Can we run those numbers? 54. 54. Oh, I love it. 54.6. Okie dokie. So I'm going to write 54.6. Now, you tell me, is there enough room for a third angle up there?
Yeah.
All right. What is that third angle?
53.
Does anybody concur with Ken? All right. Very good. Now, here's the hard part, friends. If there were going to be a second angle, excuse me, a second triangle, can I make it a little bigger there? If there were going to be a second one, this is 72, this is 7, and this is 6. That's the only information I'm given. Who's to say that that 7 swung out to the right? Maybe it swung out to the left. What do you think about that? No. Is it possible?
Oh.
7 compared to 6?
Yeah.
Try again.
No.
No, it's not possible. 7 is longer and it wouldn't reach. But let's pretend like and this is no fault of Kenneth. Kenneth is learning just like everybody else. But let's pretend like we're all in Kenneth's situation. We're like, yeah, maybe that is possible. Run the numbers. Okay. So if this right here is big A, and this is big C, and this is big B, what's this big B on the bottom going to be? The supplement of 54.6. Now, fellas, tell me what's the supplement of 54.6? How about 125.4? Double check my arithmetic for serious. Now, is there enough room for a third angle? So that's why this is not possible. And in this scenario, you only got the one triangle possible. And by the way, now that you found big B and big C, can you go ahead and find little c easily enough, make a new proportion and just solve it out for little c?
Yeah.
All right, Finley. Kenneth?
It like I was too like calculating. Can you go through that random number? You go through
What numbers?
to like find the 200 or the 175.
Oh, these two are always supplements of each other. The idea, hurry up, Finley. The idea is that if I've got correct. Okay, so a measure of angle 1, 2, and 3. 2 and 3 are congruent because this is an isosceles triangle. We swung that known side from right to left. So 2 and 3 are congruent, and 1 and 2 are supplementary because they make a straight angle. And therefore, 1 and 3 are also supplementary. And that's what we were saying, that angle 1 and angle 3 are supplementary. So once you find that first angle down your bottom right, find the next one by the next possibility by doing the supplement and then asking the question, is there enough room left over? All right. That is what you're going to do on the delta map. That's what I'm doing right now. We're going to see.
No.
When is it due? Thursday at 8 a.m. Thursday at 8 a.m. Some people haven't even started it yet. Oh my goodness. Oh my goodness. Bro. All right, look, the first 10 are easy. The first 10 are just grinded out. The last 10 are hard. I gave you 20 problems. Please don't wait till Wednesday night. You're going to be real daggum frustrated if you wait till Wednesday night. No. Because what are we fixing to do, BJ? We're fixing to talk about finding the area of a, no, we're not. I'm going to skip that. Yes. Kenneth, give me 10 push-ups. You think you can do 10, BJ? Mario, do you want to be helping him do push-ups? Then I would be quiet if I were you. All right, let's see here. Get this. Was that really 10? Sounded like 6. Sounded like 6. Ooh. Thank you, Ken. All right. Here we go. We went through a proof of the law of sines, and I hope that was instructive. Are you responsible for knowing how to prove the law of sines? No. We're going to go through a proof of the law of cosines. Are you responsible for remembering how to do the proof of the law of cosines? You are not. All right, but I do want this picture drawn in your notes, so go ahead and draw it. This is a big old fat triangle A, B, C. And typically what we are given in a scenario like the law of cosines is we're given a side angle side or a side side side. We're given information like little a, big C, little b, stuff like that. But what I've also done here is I've dropped an altitude. Remember what we talked about an altitude last week? I've dropped an altitude calling it h. And what that's done is that split up side b into b minus x and x. Okay, so in other words, this little leg right here is unknown. Little leg right here.
Is
Unknown.
the height right there? Where's the height right there?
Yep. Now, what we're going to do in this proof is we're going to talk about the area. And I bet that Andrew remembers area of a triangle. What's the area of a triangle, Andrew? Very good. 1/2 base times height. So what would the area of this triangle be? 1/2 h x. All right. Now, what would the area of this triangle be? 1/2 h b minus x. And if I added those two together, this doesn't feel right. This might fall flat. I'm shooting from the hip here. I haven't looked at my notes yet, so I might be misremembering. But what would the area overall equal? 1/2
B.
BH. I don't think that helps us any. Oh, well, shucks. Starting again. Let's not use area. Let's use the notion of cosine. Duh, since this is law of cosines, I guess we'll try that. What would the no? What would the cosine? I'm just kidding. Go ahead. What would I actually pay for your water? What would the cosine of C equal? Here's angle C. What's adjacent to C? Oh, will be this x over what? Okay, x over. Thank you. Now he's going to get water. Why was I not allowing him to use like the quote quote adjacent side as B? Very good. It's not big old. The big triangle is not a right triangle. It's an arbitrary triangle. So let's write this. Let's say the cosine of C equals h. No, not h. X over a. Right. What's the relationship between x, h, and a? Given that it's a right triangle. The three sides of a right triangle. You know a relationship from a. Yeah. Keep. No. Give me Pythagoras. All right, so x squared plus h squared equals a squared. What are we doing right now, by the way? We're kind of laying our cards out on the table. I haven't peeked at my notes, and I'm still not quite sure where I want to go with this just yet. But maybe we could replace. We want to get h out of there. I'm sorry, what are you confused about? Which of these two blue statements confused you?
What are we trying to reach?
We want to prove the statement that's in red, and I am just kind of trying to figure out where we want to go with this since I haven't looked in a while. Does the first statement in blue confuse you?
No, I don't know.
Oh. All right, let me consult my notes instead of sitting here spinning my wheels. Or maybe I just deleted all my notes, IDK. Ooh, I bet I did. Shoot. I wonder how could I get deleted notes.
That was wrong. Because you had like,
Gotta go back far enough.
you had like.
Hold on, oh, I can't go back any further. Shoot. All right, well, I'll put a pin in it until I figure it out. All right, now we're gonna do better. We're gonna say steps for proving law of cosines. Express sides using Pythagorean theorem. Okay, I like that. Similarly, BDC use Pythagorean theorem. Oh, snap, do Pythagorean theorem twice? Okay, okay. Can we go? Oh man, do I have to? I gotta write that stuff up again. Michael, help me out. What was our Pythagorean theorem? X squared plus H squared equals A squared. And then how about the bigger right triangle? H squared plus B minus X quantity squared equals C squared. All right. How about where's cosine going to come into play? We said the cosine, Kenneth's back now. Well, Kenneth, what did you say the cosine of C equaled? X over A. All right, let's do a little substitution then. I guess we're gonna play around with this. How about we get H squared by itself in the first one? Mario, can you get H squared by itself? A squared minus X squared. Can we substitute that in place of H squared in the second one? What's that going to yield? B minus X quantity squared plus quantity A squared minus X squared. No. This is H squared and this is H squared, so it's a straight swap. So it's just, and then what's that going to equal? Nope, C squared. So we had this. We had this. And now we got that. Okay, color code make pretty good sense. All right, so let's see if we can do a little bit of algebra here then. What's b minus x times b minus x? Is that b squared minus 2bx plus x squared? Anything cancel out? X squared. And then can we solve for x in this third line? Get x by itself. All right, so we'll do a swap for that. We got b squared minus 2ba cosine c. It's coming together. Equals c squared. What's x say? Okay, you got. So can we maybe kind of clean this up a little bit? And we got a squared plus b squared minus 2ab cosine of big C. And I'm going to put little c squared over there. And it looks like we've got what we wanted to. Thanks in no small part to the internet. All right. Are you responsible for knowing how to do that proof? No, you are not. But is a proof instructive for kind of where this came out? What was one of the background things that Michael Davis quoted for me that helped us figure that proof out? Pythagorean theorem. What was one of the things that Kenneth applied that helped me figure that proof out?
Right triangle.
Generally speaking, right triangle trig, SOHCAHTOA. So using Pythagoras and SOHCAHTOA together, we just proved the relationship between sides and angles in a non-right triangle. Welcome. You guys sounded great this morning, by the way. And we're recording this lesson, and I'll put it on YouTube so y'all can catch up with you guys. Finland.
Are you from the e squared minus 2dx plus x squared plus x?
This x is the same thing. I didn't color code this substitution, but I will. Let's do
As cosine c.
x is the same thing as a cosine c. And that was from that piece right there. Does that make sense, Finland? Well, cosine c equals x over a times both sides by a. So we got a cosine c is the same thing as x. So I swapped out this x and put a cosine c. Then we rearranged those two factors to keep them alphabetical. We rearranged these two terms to keep them alphabetical. And then we pulled the c squared over here just to match it with the structure of that original.
So is that the equation?
Okay, so let's talk turkey. What is the law of cosines? I'll write it up on the TV screen here. It's boxed in green at the top, but we got a squared equals b squared plus c squared minus 2bc cosine of a, or b squared equals a squared plus c squared minus 2ac cosine of b, or c squared equals a squared plus b squared minus 2ab cosine of what? C. Big C. Okay. Do you have to learn all three of them? You do not. Just learn one of them. Just learn one of them. Now, the structure hopefully matches. And let me pull my next screen up here. The structure matches to where whatever angle you're given, that's how you want to, that's which one of the ones you want to use. BJ, you had a hand up. Sure, BJ. Kenneth, you got no leg to stand on. You had to go potty or go get water. Use one of my cups while you were at it. You went to the nurse's office to get a cup?
Right there.
You bothered our sweet nurse for a
I
cup?
also need a nano because I've become the brace timing.
Oh, that's a headache right there. You know what I hated worse than the brace tightening was the spacers at the beginning. You know,
Yeah,
spacers?
that hurt so bad.
Spacers was the worst.
You couldn't even use the plane. Yeah, you needed 20.
How many of y'all have or have had braces in the past or were present? A lot of people.
Mine off.
Ooh. If you hadn't had braces, then you are blessed with good teeth. What should let's pick on Freddie. Freddie just showed up. Freddie, what should I do first? I'm gonna send you back to the nurse with a more than a headache. Freddie, what do I like to do for all problems if I can? Good. We're gonna draw a picture. So we're gonna draw a picture. Now look, in this scenario, it's an arbitrary triangle. Okay. I like to put my given angle where? In the bottom left. Now that's big C. I don't know little c. So this is not ambiguous case. I'm happy. It's not ambiguous case. And it doesn't really matter where I put the other ones. Looks like this is 6 and this is 12. So the way I've got it drawn, that's going to be big A and big B. Does your drawing have to be to scale?
No.
Like, does this have to look like 80 degrees? No. Like,
Oh, never mind. It's 6. I thought it would be.
oh, yeah, you're the number 6. So this is what we would call side angle side. Okay. And one of the cases for using the law of cosines is side angle side. The other is side side side. So you might in your notes write, this is when we want to use the law of cosines. When you got side angle side or side side side. You guys that were coming in a little bit later, or from the band, Fredo, we said that on Thursday, we're going to have a little quiz on when would you use the law of sines? When would you use the law of cosines? So here's a couple answers for you as to when you would use the law of cosines. And when you use the law of sines, we talked about earlier this week, and it would be when you, where do I have that located? Right there, when you have AAS, ASA, or ASS. Okay. That was the dirty word you said earlier.
Big one. I of A over little a.
Yeah, the fractions is law of sines because it's got sine in it. And then this stuff on the TV right here is law of cosines. Law of cosines? Nope. I like law of cosines a lot better. I feel like the law of cosines is way easier in my mind than law of sines. All right, so here we go. I'm going to put up my formula here. Little c squared equals little a squared plus little 12 squared there, little b squared, minus 2 times 6 times 12 times the cosine of 80. And the reason I like the law of cosines is all I have to do is just plug all of that into the calculator, run the numbers. And if you really want to be fancy and fast, you could take the square root of both sides before you plug it in. And you can just type all of that in right off the get-go. Okay. So let's do square root 6 squared plus 12 squared minus 2 times 6 times 12 times the cosine of 80. What mode should I be in? Degree mode. All right, so we hit that. And we get about, let's say 12.45, 12.4, whatever. C is approximately 12.4-ish. All right. You would take the square root after the fact. All right. And now what's missing? Good job, Blake. Which one do you want to find? All right, big B. We're going to find big B. You know how I'm going to find big B? Law of sines. And so we'll do sine of 80 over 12.4. Now, we practiced, Aiden, we practiced this a little while ago at the beginning of today's class. What are you going to do to both sides to get sine by itself? Very nice. We're going to put that 12 up the top. If you're in the good habit, which I've recommended that you guys put your unknown up top, then all you'll have to do is you won't have to cross multiply. You just times both sides by that denominator. And then, Christian, what do we want to take of both sides to get big B by itself? Very good. So we're going to take the inverse sine of both sides. Find what big B is. Anybody got a number for me? 72.4 degrees. Now, do I have to fiddle fart around with anything else as far as law of sines or law of cosines to find big A? Because I now know 2 out of my 3 angles. So we get to do a subtraction from 180. All right. So 180. So it looks like 27.6. 27.6. And there we go. Okay. Find all the sides, all the angles. It's law of cosines. Okay. Questions, comments, concerns? I would recommend having just one of these memorized. On the TV screen here, I'm going to delete these bottom 2. I'm going to talk with you about structure real quick. Just remember, these 2 letters, in this case, little b and little c, those are the ones that get repeated. Little b, little c, and then the letter that's right here on the left will match with his big letter that's on the right. That's how you memorize those. And it almost looks like Pythagoras at the beginning. It almost looks like the Pythagorean theorem, like we talked about a minute ago. You can remember that because that's what helped us derive this law of cosines. The law of cosines is useful for non-right triangles, so that's why it's got that extra stuff subtracted at the end. Eli, did I see a hand up, or Mario? Come on. Okay. Let's practice another one there. Andrew?
I didn't know how to use law of sine for B right there.
Oh, okay. So Andrew, I love it. Suppose that I did not want to use the law of sines to find big B. Suppose I wanted to double down on the law of cosines, right? To find big B, I would do little b, which is 12, little a, which is 6, and then 12.4, which is little c, minus 2 times 6 times 12.4 times the cosine of big B, which is my unknown. Now, at this point, because my unknown is all the way like tucked in with all of this other jibber jabber, I want to start kicking this other jibber jabber to the other side. All right, so I'm going to subtract 12 squared minus 6 squared minus 12.4 squared. So that gets rid of those 2 guys. Then I'm going to divide both sides by -2, 6, 12.4. This is not precisely, by the way, how Delta Math describes to do this. I like to use the law of sines because I feel like it's simpler. Can you kind of tell that now? Right. But to this point, could we now use the inverse? Like, no, you can do either one. You can do either one. Inverse cosine. Thank you. So we take the inverse cosine of all of that jibber jabber, and that's what we wind up getting for B. So as an exercise, why don't you try typing that in with me here? Okay, let's do, no. You and your illegal water vessel that you tore your mom's name off of. Okay. Here we go. Inverse cosine. I'm gonna go ahead and set up fraction. we're going to do 12 squared minus 6 squared. When you're doing it this way, you do have to be careful about the signage as far as like what's positive and what's negative. 2 times 6 times 12.4. Close parentheses, hit enter, get about 72.1. Now, we got 72.4. Why would my answer using law of cosines be more of an approximation than my answer was using law of sines? Because we used an approximation multiple times in the process. 12.4, not only did it show up twice, one of those times it was getting squared. And if you square an approximate value, you're increasing the error. Okay, so that's another reason. Who asked that? Was that Andrew? Blake. So that's another reason for why I would suggest using the law of sines once you find that missing side. Using the law of cosines, I would default back to law of sines. Not only is it simpler in my mind, but also you're only using an approximate value once. Ready?
When you're looking for riddles to be.
Oh, because, good question, Freddie. This formula, like let's pretend I'm looking for a little a here since I've got a little. What would I do to get little a by itself? I would take the square root of both sides, and I've got little a by itself. Good question. Okay. Yeah. Now Blake picked big B, and we ran with it that way. We certainly could have found big A first. Now, suppose that you have a little bit of an issue. All right, and I feel like I'm responsible for teaching you guys how to use the calculator successfully. Suppose that you have a little bit of an issue, and you're like, Coach Morgan, I ought to be able to get a better value than that. Okay, so like even both of these values, when we did inverse, sine, I don't think I ran this on my calculator. 12 sine 80, close parentheses, go down, divide by 12.4. All right, like both times, we got close to 70. We got close to 72. Would you like to know on your calculator how to get the exact value?
Sure.
Like the legit value? Instead of using 12.4, watch this. Do y'all remember the stow option? Store that for your variable. What was 12.4? It was a little c. So I'll just store it as c. Okay. And then I'll go up here, and instead of 12.4 squared, I'll just type a what? I'll just type c. And I do delete, 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 and then put c in there. Uh-oh, that's something. There we go. And then instead of 12.4 down here, now you have to have a little bit of foresight in doing this, right? You have to kind of plan ahead to do this properly. So now I get my value, and this is the truer value, 71.66. Can we also check that using the law of sines? You bet your biscuits we can. So instead of 12.4 on the bottom, what should I hit? We're going to do C. And we get a better value there. Now, those numbers are still off just a little bit because, truth be told, when what did we say C was? Uh-oh, I hit the wrong button. Yeah, we hit C. The calculator only has so many decimals, so we had to round when storing C. And how many decimal spots did that round to? 8. So we rounded to 8 decimal spots, and so that's why these two values right here, 71.6655096 and 6655091, that's why those were off just a smidge bit. Okay, but not. That's a negligible. Let's see here. What is 180? Oops, hold on. 180 minus that minus 80. You got 28.3. 28.3 is a better approximation than 27.6. Because once in red, once we found big B was 72.4, and we said that was off because we had done a little bit of calculations with approximate values, then that also made 27.6 a little bit off. So here's my recommendation. Okay. Delta math in the practice problems that you guys do with law of cosines, just watch how they do it and do it how they do it, but be aware that sometimes you're going to get values that are off kilter just a little bit. Okay. On Thursday, we are not going to have any kind of quiz questions regarding law of cosines. Law of cosines is fresh and new today. I'm not going to quiz you about that Thursday. What I'm going to quiz you about Thursday is this most recent homework that I asked y'all to work on. Law of sines. It's 20 questions. That's plenty of practice. If you practice those 20 questions on Delta Math, you'll be ready come Thursday. Just also know when to use the law of sines, whether it's angle side side or angle side angle, etc. Like, no, it will. Okay, I just literally got through saying law of cosines is not on the quiz. It will look like these questions right here. And it will also have, hey, Blake, write down the law of sines. And hey, Blake, when should you use the law of sines? By fair and comfy with that? All right, then our class is over. Let Jesus in our hearts. Y'all have a wonderful day.